Good day everyone. Welcome to another video on Python basics. In this particular video lecture, we will discuss about the Numpy library. So Numpy library is one important library that is used for doing the operation on the matrices or on the arrays. As you will see later in the lectures that most of the operations in machine learning algorithms are matrix operations, so it is necessary to understand this particular library and various functions associated with this library. So the first thing that for using this library in your Python code, you have to import numpy, and in our Python we can give alias to any library. For example, you can give it as an alias as np. So now whenever you want to use numpy library or any submodule in the numpy, instead of using a numpy you can use np. Okay, and the first thing that we will understand in np is to create a 1D array. So let's see how we can create a 1D array. So we have already discussed the list. So let's suppose this is a list. Okay, so let's say it has 3 elements. Now list is different. List is a collection of items, and these items can be of different types. Okay, and you can change the any element of the list, but there is a difference between a list and an array. Okay, so to create an array from a list, let's suppose I want to create an array. So what you can do, np dot array. Okay, and then you can provide the argument that is to be provided here is a list. Okay, so you have to provide a list here as an argument, and it will create an array, and that array will be stored in this arr variable. Okay, so let me give the argument list1. Okay, then you can print this particular array. Okay, let me run it. So it is giving 1 2 3. Okay, this is an array. Fine. Now another thing is that instead of giving a list like this, the name of variable, you can simply write a list here. Let's suppose 2 5 6, and it will create an array out of this. So it is 2 5 6, and you can access the any element of an array using as we already know, the index, and index always starts from 0. So it is 2, the 2 is the third element, which is 6. Okay, or so you can see that using np.array we can create an array from the list, and this is a 1D array. Okay, so let me write it as 1D, or you can simply create 1D array as like this, np.array, and give the argument a list. Fine, and you can see the dimensions. You can also print the dimensions of an array. Let's suppose you want to print the dimensions. Let me rub it here. Print array array 1D dot end. So it will print the dimensions of this array. You can see that this particular array has only one dimension. It is a 1D array. It is not a 2D array or 3D array. So since it is a 1D array, so it will print only 1 here. Okay, now let's see how we can create 2D arrays, 3D arrays, ND arrays using this np.array. So you already know that a 2D array is a combination of multiple 1D arrays. So in a 2D array, each row is a 1D array. Okay, so 2D array is created by stacking 1D arrays on top of each other. Okay, so let me create a 2D array. So how we can create? Same np.array, then the argument should be a stacking of arrays. So what I mean to say, the elements. So you can see that here the elements of an array are written in square brackets. For a 1D array, each element is an integer. So here each element is an individual number. Okay, so but for a 2D array, each element is itself an 1D array. So each element of a 2D array is a 1D array. Okay, so we have to write the elements inside the square bracket. So what are the elements of a 2D array? Elements of a 2D array is again a 1D array. So let's suppose this is the first element, or we can say the first row 1 2 3. The second row will be, let's suppose, 3 4 5. Okay, so again the 2D array will be written in square brackets, but inside those square brackets each element will now again be a list. Okay, so I have written two lists here. That means these are two 1D arrays. Now you can print this particular 2D array. Okay, so let's print it. You can check the first is 1 2 3, then the second row is 3 4 5. Fine. Likewise, you can create a 3D array. How we can create a 3D array? So what will be a 3D array? 3D array, in a 3D array, every element is a 2D array. Okay, so we will do np dot array. So the elements of this of 3D array are 2D arrays. So let's first write one 2D array and then second 2D array. So let's write the elements of one 2D array. Okay, the other elements so you have to keep in mind where to put the brackets and other things. So it is a 2D array. So it is a 3D array. So in this 3D array there are two elements, and each element is a 2D array. Okay, and itself 2D array, in a 2D array each element is a 1D array. Okay, so let me print this 3D array. Okay, let me print it. So you can see here I am printing this. So basically this is a 2D array I am printing, and here this is a 3D array. So in this 3D array there are two elements. So this is one 2D array and this is another 2D array. Okay, now you can also print the dimensions of each of these arrays. Print array 1D, the dimensions of this, comma array 2D, dimensions of this, and array 3D, dimensions of this array. So the 1D array will have one dimension, 2D array will have two dimensions, and 3D array will have three dimensions. Okay, so it is printing here 1 2 and 3. Now there is another function that is, or we can say another utility that is provided by the NP, is that you can find the shape of an array. Okay, shape means how many rows are there and how many columns are there. For example, print, or I can write it print np dot shape, and we want to find the shape of, let's suppose, array 1D, and we also want to find the shape of let me write it here, dimensions of 1D array. Okay, then dimensions of 2D array np dot shape. So using the shape function we can find the dimensions and print dimensions of 3D array. np dot shape array 3. So you can see that what should this print, what is the dimension of 1D array. So you can see which 1D array we are using, this one. So here dimension is, so it has one row and three columns, so it should be 1 comma 3. Okay, this one should be 2 comma 3 because it has 2 rows and 3 columns, and this one should be, so how many rows, columns, it should be 2 comma 2 comma 3. Okay, so let's run it here. See, dimension of 1D array 3. Basically it is 1 comma 3, so it is giving it like this. Dimension of a 2D array 2 comma 3, and dimension of 3D array 2 comma 2 comma 3. Okay, so you can find the dimensions like this. Also, as I said, you can index, for example, you can we can say accessing the arrays. So 2D array is also called a matrix, you already know that. Okay, so how we can access the arrays? For example, if I have to access any element of a 1D array, so let's suppose a is equal to array 1D, I have to get the fifth element, or let's suppose only second element. So here I can access it like this. So it is array. Okay, now let's suppose if I have to access the access some element of 2D array, so there I need two dimensions, row and column. So let's suppose b is equal to array 2D, and I need a element in the second row, and in the second row and the third element. Okay, now if I print it, so you can see, oh sorry, I'm not printing it, so let me print a comma b. So I have to print these two elements. See, it is 6. You can see the 1D array was this one, and the element at index 1, element at index 2 is 6. Okay, now in the 2D array, so this is our 2D array, you can see the element in the second row, this is our second row, this, and the third element is 5, so it is 5, so it is printing 6 and 5. Okay, now there is another way you can slice the arrays. Okay, you can slice means that you can take some part of the array. Okay, let's take the example. Let me create a new code section here, so where we will check slicing of arrays. Let's first understand it on a 2D array, on a 1D array. So let me create a 1D array. So we can create simply like this, np dot range, let's suppose 1 to 20 with a step of p. Okay, you can also print it 1D. You can see that it is creating an array. So how many elements are there? Up to 19, 1 to 20, as I said, a range, and step size is 2. Okay, so it is creating an array like this, 1D array. Now let's say I want to get the elements from index 3 to the end. Okay, so I need elements from this array, or I can say I have to slice this array, and I have to take only some portion of the array. So where from? I am taking from index 3 to end. Okay, either I can write end or I can leave it here. So it will take from 3 when something is not given, that means to the end. Okay, or I can do from index 3 to, let's suppose, index 6. Okay, so what are the elements from index 3 to index 6? At index 3 we have 7, 9 and 11. So in A we should have print, so A will be an array. Okay, but it will have elements only some portion of this array. So we are slicing this array from index 3 to index 6. You have to remember that index 3, index 4 and index 5 element will be in the A, not the index 6th. So it will be excluded, 6th one. Let's run it. So what is 7, 9 and 11? Let's first check what was the 1D array, so that we can cross check it here. Here 1D array was 1, 3, 5, 7, 9, 11. From this array we are taking from 3 to 6. So 3 is 7, 9 and 11. You can see that 7, 9 and 11 are here. Okay, if I remove this 6, then it will go from 3 to end. So you can check from 3 7 9 11 up to end. Okay, or you can do, you can remove the first one also. When you are removing the first one also, it means start from the beginning to the end, so it will take the entire array. See, it is taking the entire array. Or you can do like this, for example 6. When we are skipping the first one means by default it will take from the start. So from the start 1 3 5 7 9 11 up to index 6. Okay, or you can also use negative numbers here. So let's suppose if I am using -4, when we are using negatives, it means from the end. So we have to start 4 from the end. So fourth index from the end is 13, this one. So we will start from this to end. So let's check it here. So you can see 13 15 17 19. If I am using -6 to -2, let's say, it is taking from starting from -6. -6 will be, this is -1 -2 -3 -4 -5 -6 9. Okay, to -2, -2 is -1 -2 up to this, but this one will be excluded, so up to 15. So let's check. So it is 9 11 13 15. So you have to remember. So I will write in comments here. Let's do it like this, or b, another slicing is b is equal to array 1d 2 to 9. Okay, you can do like this also. So I will write in comments here, negative means from the end. Okay, so this is how we slice 1D array. So let's check we can, how we can slice 2D arrays. Let's make another section here. So slicing 2D arrays. Okay, so let's create a 2D array. And so this is a 2D array. Sorry. Okay, you can also print this 2D array. So let's check. Oh, sorry, np.array. Sorry, I have used only one bracket here, so I have to use 2 square brackets because it is a 2D array. Okay, let me print it. So it is a 2D array. Now let's suppose you want to slice it. Slice it means, let's say you want to take the elements from the 2 rows but only 3 columns. Okay, so array 2D, you need the 2 arrays, you need both the we can say both the rows, the first row and second row. So I need all the rows, and in the columns I have to start from the 0 up to, from index 0 to, or we can say from the start to the third one. Okay, so let's check it here. Oh sorry, I have to print it also. Print a. See, we can slice it. Okay, so you can check it here. So both the rows I have taken and only columns I have taken from the start to the third. So this is how we can slice 2D arrays. Okay, so I hope you understood what are the different ways of slicing. Now let's suppose you have an array. Okay, so let me add another code section here. Let's see how we can use another function which is called a reshape. Let's suppose you have some array and np.array, and these are the elements 1 2 3 4. So it is a 1D array, one dimensional array. Let's suppose you want to make it a 2D array. Okay, so you want to make 2D array means 2 rows. So it should have 2 rows. So you want to convert this array, which is a 1D array, into a 2D array, and that 2D array will have 2 rows, and each row there will be 2 elements. So how that is done is we write array dot reshape, and in the reshape we write new dimensions. So what should be in the new dimensions? 2 rows and 2 columns. Okay, so now if I write it, sorry, if I print this now array, it will be a 2D array. Okay, so let me print it. You can check it here. Okay, sorry, array dot reshape. Sorry, I have to put it in another variable. Now let me write it, so you can check. 1 2 3 4. So it has reshaped this particular array. It has converted it from a 1D array to a 2D array with dimensions 2 cross 2. Okay, so this is how you can reshape any array into any other dimension array. Okay. So this was about the NP, how we can create 2D arrays, 1D arrays, 3D arrays, or ND arrays, and how we can slice those. Now let's see what are the different operations that we can perform on the arrays, or not on the arrays, but let's take the matrices, because we will be mostly discussing about the matrices. For example, how we can add two matrices, how we can subtract, how we can multiply matrices. Okay, so let's check these different operations in, so matrix operations using Numpy. Okay, so let me create a 2D array. So we will be discussing mostly about the 2D arrays. Okay, np dot so let's create, or let's do one thing, list 1 np dot arrange 5 to 20, and list 2 is equal to np dot arrange 10 to 25, list 3 is equal to np dot arrange 15 to 30, list 4 is equal to np dot arrange 20 to 35. So I have created 4 lists, list 1, list 2, list 3, and each list has 15 elements. So let's create more lists. np5 is equal to np dot arrange, let's do one thing. Instead of having 15 elements, let's have only 3 elements, 5 to 8, 10 to 13, 15 to 18, 20 to 23, and sorry, it is 23, and 25 to 28. So list 6 will be 30 to 33. So I have created 6 lists, and each list is of has 3 elements. Okay, now using these lists, let's create 2 arrays. Array A, okay, np dot array, and this array will have, it is a 2D array with list 1, list 2, and list 3. So it will have 3 rows. So row 1 will contain elements from list 1, row 2 will contain elements from list 2, and row 3 will contain elements from list 3. So it will be a 3 cross 3 array. You will check it right now. Let's create another np dot array. So it will be an array with the other lists that we have created, list 4, comma list 5 comma list 6. So I have created two arrays. We can also print these two arrays. So print A and print B. We can also print their shape. Print A dot shape comma B dot shape. You will check both have the shape 3x3. So let me run it. Okay, so you can check this is A and this is B, and both these are 3x3. Now let's check how we can operate on these two matrices. Okay, so let me comment out these things here because we don't need them now. Okay, so how we can perform, let's do the addition. Okay, how we can perform the addition. Let's suppose I want to store the addition of A and B in C. So we can do np dot add. So it will do the addition of matrices A and B, and it will do element wise addition. Okay, you can also print C. Let's check whether the result is coming out correct. So let's keep these two as well so that we can cross check from here. Okay, so this is our C. So you can check that it is an element wise addition. See, 5 plus 20 25, 6 plus 21 27, 7 plus 22 29. So the result is coming out okay. Okay, so this is the addition. Now you can also do subtraction. Let's do one thing. Let's format it. Matrix A is matrix B is addition of A and B is. So for subtraction we can use subtract. So it will subtract B from A. Okay, and we can also print it. Print subtraction of B from A is. Let's print this. Okay, so let me run now. Okay, so this is our matrix A, this is our matrix B, this is the addition, and this is the subtraction. You can cross check also. Now let's see other things here also. Let's see the transpose, how we can find the transpose of a function. Transpose A transpose, let's name it. So A transpose, we can simply do A dot T. So it will perform the transpose of matrix A. Okay, so let's print transpose of A is. So let's print A trans. Or you can do another thing is another way of transposing is that we can do np dot transpose. Let's transpose B here. Okay, and let's print it also. Print transpose of B is print B. Okay, let's cross check it once. Let's run it. Okay, so this is the transpose of A and this is the transpose of B. So these are the two ways by which you can transpose any matrix. Now let's suppose you want to do multiplication of two matrices. So there are two multiplications. One is the element wise multiplication. First element is multiplied with the first element, second with second, third with third. Another is the general matrix multiplication that we usually do. Take the first row, first column, then multiply. First row, second column. Okay, so there are two different multiplications. Let's first do the what that is called, so point wise matrix multiplication. Okay, and how we can do the point wise matrix multiplication? You can simply do, let's suppose I want to do the point wise multiplication of A and B and store the result in res. So we will do np dot multiply, so multiply A comma B, so it will do the point wise multiplication. So we can also cross check point wise multiplication of A and B is, so let's print it, print, so let's check. So this is the for example, it was 5 into 2 20 100, 6 into 21 126, 7 into 22 154. So it is doing the point wise multiplication. Okay, but mostly we need the actual matrix multiplication. How we can perform the matrix multiplication? That is done by another function which is called np dot. Okay, so let's do result 2 is equal to np dot A comma B. So print the matrix multiplication of A and B is print. So let's print it here. Okay, let's run it. So it is doing the matrix multiplication of A and B. Fine. And another way is you can also write it like this: A dot B. Okay, so let's print. You can see that these two are same. Okay, so either you can perform matrix multiplication like this or you can perform it like this. Okay, so both ways are one and the same thing. Okay. So this is for the matrix multiplication. Now let's see, for example, let's say you want to find the determinant of a matrix. So this is a matrix, you want to find it as determinant. Okay, so how we can find the determinant of a matrix? So we are using np's linear algebra library or submodule np dot lin algebra dot determinant of A. So let's name it determinant of A. Okay, so then we can do print determinant of A is comma. Okay, let's print it here. Determinant of A is 0, so it is coming out 0. Fine. And likewise you can find the determinant of B as well. See, let me copy paste it here. So let's name it B. I think B's determinant will also be 0. Okay. B. No, it is coming out something, but determinant of B. But if you cross check, it will be correct. Okay, so this is how we can find the determinant of the matrices. Or let me do one thing, let me create a new matrix, mat np dot array. So let's create a whose determinant will be non-zero. Okay, 2 7 1. So you have to be very vigilant while creating these two-dimensional arrays. Okay, so here I have created one matrix. So let's find the determinant of that matrix. So let's remove other things here. That. So let's run it now. Okay, so it is coming out 85 point something. Okay, determinant of this matrix. So A, the determinant of matrix A was 0. So that means it is a singular matrix. And we don't have an inverse of a singular matrix. You should know this from the linear algebra related to the matrices, that the determinant of whenever we have a singular matrix means whose determinant is 0, for that particular matrix inverse does not exist. Okay, now let's see if we have to find the inverse of a matrix. Okay, let's take the inverse of this particular matrix, mat. Okay, so how we will do is inverse of mat, it will be, so this is the variable name, nothing else. Okay, so how we can find the np dot in algebra dot inverse and inverse of mat. Okay, and then we can also print it. We can print inverse of mat is, so what is the inverse? Print inverse mat, so it will do the printing. So this is the inverse of this particular matrix. Okay. Now let's check, we can find the inverse of a singular matrix, of A matrix. Okay, let's see the inverse of A. Because it is a singular matrix, the inverse should not exist. Okay, so lin algebra dot inverse of A. Let's see whether it is giving some error or not. Yes, it is giving an error. Okay, and you can see that it is raising this particular this particular exception, which is raise linear algebra error singular. Basically it is a singular matrix. You can see here singular matrix, and the inverse of a singular matrix does not exist. But there is one way of finding the inverse of a singular matrix. That is not the actual inverse, but that is also called a pseudo inverse. Pseudo inverse. So you should go and recap the discussion related to the inverse of matrices. There is one inverse which is called a pseudo inverse, which exists for the singular matrix as well. Okay, it is not the actual inverse, you have to remember it. And how we can find the pseudo inverse? That is by using p inverse function. Okay, now I can print the inverse of this particular matrix. Print pseudo inverse of A is, so we will print it here. Now it will have its pseudo inverse. So you can check, this is the pseudo inverse of A. Okay, so now we discussed about the numpy. Now one important concept, or we can say only one remaining concept is there, that let's suppose there was one thing called a reshape. So what was reshape? Reshape was changing any type of array into a different dimensional array. Okay, so there is another function called flatten. Okay, so what is flattening doing? It is converting any array into a 1D array. Any array. So let's suppose we have a 2D array. 2D array with 2 rows. Okay, so let's suppose there are 2 rows, row 1 and row 2. If we flatten that particular array, it will become a 1D array, and the elements of that 1D array will be, first will come first row, the elements of first row, then will come the elements of second row. Okay, so let me flatten the array A. Flatten A is equal to np dot flatten A, flatten, sorry, A. Okay, so print flat A is print. So let's run it. So what was A? 25, 27. So no, sorry. So this was A. 5, 6, 7, 10, 11, 12, 15, 16, 17. Now after flatten, it should become 1D array. So what is the meaning of 1D array? First it will come 5, 6, 7. After that there will be 10, 11, 12. Then there will be 15, 16, 17. So let's check it. Oh, sorry. It is given some array. Oh, sorry. So this is not how we use np.flatten. We simply use a.flatten. Sorry. Okay. So now, so you can check it here. 5, 6, 7, 10, 11, 12, 15, 16, 17. So these were the important functions that are useful in the NumPy that we will be using in our machine learning exercises. So I have tried to cover almost all the important details that are required, but for deeper discussion you can search online and find more about the NumPy library.